All right, who's first? Josh, did you get this one?
I'm a little confused by it, but
How many maxes are there?
it should be one.
There's one there. Let me get red color so y'all can see it really well. So this should be one. And do you see any others?
It'll be on the far right.
Right there?
Yeah, I can't tell if the point to the right of it goes higher, but
Oh, because I stopped it. Yeah, it should be an arrow right there. It's kind of hard to see
okay.
because it got cut off. But yeah, that
Yeah.
should definitely be a an arrow happening there.
Yeah. So the absolute max should be the one on the right.
Well, we're looking at this. We're looking at the local max. And so now you want to tell me about, we're approximating on these graphs. So just to kind of approximate where that is. That first one's where?
It's at like 15.
Yeah. I'd say like anywhere between like 15 and like 19 probably is fine. Something there.
Okay.
15 and
Maybe 15.
what's that other one?
Oh, it's at, I want to say like 25 to in between 25 and 30.
Somewhere in there. 15, 25, 17, 27, something in that ballpark. I think the book says 17 and 27. I think it's what they're saying.
Okay.
What about absolute max? Is there an absolute max on this thing?
No.
Is that 25 an absolute max? Why or why not? No clue.
I thought it might be because it's the highest point, but then there's an arrow. So
Yeah. There's an arrow there, so that keeps going. So that keeps going higher than that 25. So since it keeps going, if they ask, you should absolutely put something in there like none or something that shows that there is none. What about the mins? How many mins are there? It's kind of hard to ask you to point them out. But I think those two things are my mins. So what numbers would you give me for those?
like for the coordinates, -1, -10.
So we just want the y value when we talk about mins and maxes. We're talking about the mins and maxes of the function. So it should just be the y value. So I think you said what, -10?
Yeah.
And then the other one's right at where?
Like 23, 24 maybe.
Yeah, somewhere around in there. And the other thing, is there an absolute min?
No.
No, why? Because of that guy right there, right? Okay.
Please, can you go slow down here?
Go where, what?
We can read with the exercise because I'm confused. Please. Here, okay, here you said the minimum is -10, right? The smallest one.
The local min is -10 and it's the 23. It's anywhere where we have a vertex that's kind of going down. Anywhere there's a turnaround point. So we have one like where x is like -1, 10. That's giving us the -10. And then we have another one that's like 3, 23. That's also giving us another min. So the
But-
mins are the y values of those points, which are the
Okay,
minus
okay.
10 and the 23.
How about the max here?
The maxes,
Yes.
so the maxes are occurring at like negative 1, 2, 3, 4, like negative 4, and that's about like 15 or something like that. So minus 415 is another peak. It's a vertex peak. And then there's another vertex peak happening at like 225. And so we just want the y values from those points. So that would be the 15 and the 25. And then as far as absolute, there's no absolute because we have arrows that keep going, right?
You mean when we have the arrows, it's no absolute. But when we talk the absolute, when we have a point, like it's stopped, right?
So if it ends at a point or if it doesn't keep going up, right, we will have an absolute. Here we don't have any because there's an arrow going up. This tells me that we have no absolute max because any point I pick on my graph, that arrow is going to keep going up. I can pick a point on that arrow that is above it.
Okay.
There's no point that's higher than every other point on that graph. And then I know it doesn't have an absolute min because it has this arrow going down.
Yeah.
So
Okay.
any point on that graph, I can pick a point from that arrow, right? That's going to be further down. It keeps going down.
How about the local extrema? We have 3 points, the local, or no, 4.
On which one?
Local extrema.
I'm not sure I understand what you're saying.
About the local, LOCAL, local extrema.
Local extrema?
Yes, we have 4 points, right?
Yeah, so there should be 2 max
And 2 men. Yeah.
and 2 min. Yep.
Yes. Okay, thank you.
Yes, yes. Any other questions? I think if I erase this, I can just, oop. Oh. Can I erase it without erasing that part? Okay. Next, Kathleen.
I was kind of confused on these as well, but I think I did 21 right.
Okay.
For the local, I put 4, the
Yeah,
local
so-
max.
So how many local maxes do you see here?
There's 2.
Okay, there's 2 points, and they are both the value of 4. That's it.
Okay.
What about
And then-
local min?
I don't think there is one. Or is it 0?
Right here, right? Anytime it's got a vertex, that is either a max or a min.
Okay.
So just like put a point on all the vertex on all the little vertices you see,
Okay.
basically. And that is at, you said it,
It's 0.
0.
Okay.
Absolute max. Is there an absolute max here?
Would it be 4 again?
It absolutely is.
Okay.
And then my absolute min.
And then it goes on forever, so there isn't one.
Yep, there's none.
Cool. Okay.
Questions on this? So if I pick 4, right? If I pick 4, can you give me a point on this graph that's going to go above 4? Nope. That's why that thing's absolute here. There's no arrow going up. We should have an absolute max. And this is what, 1321. I believe the next one was what, 23?
27.
Okay. Questions? Are we getting these? My advice is really like I kind of said, put a point on all your vertices. So if I'm looking along here, who's next? Leslie was next. If I'm looking along here, how many maxes do you see?
2.
Yeah, there should be one right about here and probably one right about here. So what values are those giving me?
So would one be 0.5?
Mhm.
And the other one 2?
Yep.
Okay,
And then the local mins, how many mins do you see?
there's 2.
There should be one right here and one right here.
And so would that one be negative 0.5?
Yep.
The other one, or is it 2.5?
I think it's hitting right there at the 2. Is that what you're saying?
Yeah, negative 2. And
Now, what about absolute? Is there a point you can give me that it doesn't go above?
would it be? I don't understand that much about that. Would it be the points at like where it stops?
Yes. Is there like some sort of like value you can give me here that it doesn't go above?
Um, I don't know what those points are. Is the first one like 3.5? Is it negative 3.5? I'm not sure. Or is it 0.5?
Where are you drawing your numbers from? That's what I'm wondering. Because it should be just like this thing right here. So does it go above that 2? It should be one of your usually it's one of your local maxes or mins if it's not an endpoint.
Oh, really? So was it?
So this should be 2, right? So if I tell you 2, does it ever go above this line?
Oh no.
Yeah. And is there a line that you can give me that it doesn't go below?
Is it just 0.5?
If I do 0.5 is like right in here, right? Or right in here. Sorry.
Is
So how far down can we go?
I don't know.
If I go here, can I keep going?
No.
Does it go below that?
Yeah.
Yeah. So does it go below this thing?
No.
So we're just looking at this graph. We're seeing what is the point like that's downmost, right?
Mm-hmm.
The lowest point on this graph.
So is it just 2?
So the lowest point on this graph should be like this point right here.
Oh, that one.
And we're looking at the y value of what that lowest point is. So yeah, so -2 should be it. That cleared up a little bit maybe?
Mm-hmm.
Okay. So yeah, we're looking at basically the highest point on the graph. What is the point it doesn't go above? That would be the 2. We're looking at the lowest point on the graph. What is the point that goes below? We can't keep going down from here, right? If we go down, there's no graph down in here. Any questions over these 3?
Yes, I don't understand when you say it confused me. Sorry.
Okay. So what part, I guess, is what I'm trying to get at.
Yeah, we can read it again because it confused me about the highest, the max, the minimum.
All right. So locally, we're talking about every vertex that's on here, right? You basically want to give me every vertex that's on here for your local maxes and mins. If it's at the top, if it's a vertex that looks like it's a max, like these two values are giving me what? 0.5 and 2. So the point that's where around like -2, and then it's like got a y value of 0.5, that's giving me a max.
Excuse me, teacher, when you said 5, it's 5 point, or you have the number 5 in the graph?
It's 0.5, it should be like a half.
1, 2, 3.
It's going
Okay,
halfway. It's going halfway between 0 and 1, right?
okay.
I guess I could have said a half instead of saying 0.5. So it should be a half, and then you also have another one up here that's a vertex at the top that says the value of 2. It's my y value there. Do you see that?
Mhm.
Okay. And so those are my two local maxes. The local mins are the vertices that are like on the bottom. And so we're looking here. This is a minus 0.5 or a minus a half.
It's minus half.
Is one of them. And then the other one is at a y value of a minus 2.
Yeah.
So those are my local mins. If I look absolutely, what is the point that this graph goes up to and it doesn't go any further?
The 2 points, one in the right, the one in the middle, the 3, and the other one is in the other side. It's the minus 3.
So it should be this 0.2, right? If I look at this 2, it
Okay.
goes up to the 2 and it turns back around. And so if we look at this 2, this graph doesn't come up here. It stops right there at the 2 and turns around. And so if I want an absolute max, the point that it goes to and doesn't go any further would be that 2. If I turn around and I want my local min, this graph goes down to minus 2 and then it comes back up a little bit. So if we look at this minus 2, this graph does not go any further down here. That is the lowest point on the graph. So we're basically looking at the highest point overall and the lowest point overall.
In this case, the lowest point is minus 2.
Yep. That's my absolute min. Yep.
Okay. Thanks so much.
Any other questions? Oops. I'm just going to clear all this. All right. I think we have one other one. Next page. What are you doing? 35. Did y'all do 35? Did you get through all these?
No.
So I like kind of give you a hint. But what's the first thing I'm probably going to do if they don't give me a graph? Not everyone all at once. So if I don't have a graph, what am I going to do?
Put it into your calculator.
Just put it into, draw a graph somehow, right? And if you want to put it in your calculator, okay. This one you should be able to draw. This is x squared plus 1. What does that look like? I know everyone's favorite section is those graph transformations, so let's do this.
Parabola.
X squared plus 1, that looks like a what?
Goes left with 1 and up.
Parabola.
It's
Parabola
like a parabola and it's lifted.
Positive parabola.
with 1.
It's lifted up 1, basically, right?
Up, yes.
If you draw that, I think the rest of it. Max and min. So locally, what are my maxes and mins? Is there a local max?
In 1, right?
No.
No.
So we don't see anything that looks like one of those things, right?
What?
The curvy line looks like that kind of curve. Curves
But
up.
when we said the vertex, here our vertex is 0, 1, right?
Yeah, so there's only one vertex. And is that a max or a min? I guess that might be a better question, better way
A
to
min.
ask. That's a min.
Minimum.
And there's a
It's
min
minimum
at what value?
at y equals to 1.
Y equals to
0.
1. Yeah, so we're doing the y value for our maxes and mins. The y value there is 1. Is there a local max?
No.
Put the word none, don't put the word 0. 0 is a number, none means there is none. That's my local max, my local min. What about absolute max? Is there an absolute?
None.
Is there an absolute max?
No, I want to say no.
Okay, what about absolute min? Is there an absolute min?
Either, no. No.
One.
Okay, 1.
1, right? So if we look at this, does it go below that y equals 1? What is the lowest point on this graph? It should be that y equals 1. So there is none absolute max. So there's no local max. There's no absolute max. There is a local min at 1, and that's also the absolute min at 1.
Stop.
Okay. Questions about this one? Are we getting these absolute and locals? Extremas? Okay. All right, so the next few I want to do, that is the stuff that we have on the extremis. The next, like, I don't know how many problems. They're all over the basic even odd symmetries that we talked about. So doing those two, and I want to get through the symbolic. So I want to get through the graphs and the symbolic ones next. So 53, 57, and what are the numbers? I want to do 53. I want to do 57. So the ones from here, let me make sure I got the right numbers listed. 53. There should be a 55. Did I miss it? Ooh, it's missing 55. I didn't even notice that. Let's open up my book. 53, 55, 57. So 55, we might have to open up the book to look at it. And then from here we have 61, 63. Looks like 67 and 69. So let me type that in the chat right quick, so we're all on the same page. Those three, and then 557, 61, 63, 7, and 69. That gives me 4 from the symbolic. So they give us a few graphs. Let me double check what that one is. Okay, fair enough. 55, in case you need to see it right quick. Yes, let's do screen. Here we go. There's 55 if you want to look at it right quick. Okay, and then I'm going to open up rooms unless y'all got questions. Let's get these next. What? Three graphs and then 4 symbolic. So the graphs, I feel like you should be able to look at them hopefully and like tell me, kind of hopefully right. Those should be hopefully the fast ones. I'm hoping. Symbolic, I might take a little bit more time. Okay, so I'm going to open up the rooms. Where do you want to go? A room with 3 people? 3 or 4? Let's go 4. And the pause. Is this recording? Stop share. Oh, Zoom recording. There we go. So odd is like we can rotate it 180 and it'll end up back at the same picture. And then the other thing was the even, which we can flip it about the y-axis, right? And it will end up the same picture. Any questions about these? Okay. So that's what these things look like graphically. So I don't know if I mentioned this, but in the Rockswold book, I believe there's 3 different ways they really like to like portray things, and they call it graphically, numerically, and then the third one is like symbolically. So here we're doing it graphically. If we look, let me share that other page. Turn off my annotations. Stop that. Click this page. And I want to do the crazy number thing. Why is it not on there? There we go. And so that's kind of what we have here. We have graphically here, we have symbolically here, and then they call these tables numerically, is what they like to call their tables. So we have to know what even and odd functions look like, basically 3 different ways. So Carson, did you do these? Did you get through?
I was kind of confused, like watching the notes. I wasn't really sure like where to start.
Okay. There are some checks you can do if they give you just regular polynomials like this, but we probably still want to see some work in there. So what we want to do to figure out if something is odd or even, you want to figure out what the heck that thing is. We want to throw a negative on our x. So if I take, I believe, what is it, 59? No, 61 is the next one, huh? Let's look at 61. No, let's look at 59 first. 59 is a better one to start with. So if I want to talk about 59, if I want to do f of a minus x, what does that look like?
5, and then in the parentheses it would be negative x.
So that's a 5 with the negative x. And this is really the same thing as just what?
Negative 5, yeah.
Minus 5x. How does that relate to f of x? Is that f of x if we take f of x? Is that the same thing?
Yeah. Looks like it.
These 2 things are the same thing. What am I missing here?
The 5 or the negative, yeah.
Yeah, there's a negative sign on there now. And so if we go from, if we plug in a negative and we end up getting the opposite in our y, what sort of symmetry is that?
Even, right?
You got a 50-50 shot. Let's try it again.
Odd.
Odd, it's odd, sorry. So if we plug in a negative and we end up getting the negative of our function, that would be an odd symmetry. If we end up getting the same thing as our function, right? If this ended up being a positive f of x, that would be even. So the trick to these things is throwing in a negative and seeing what the heck it spits out.
Okay.
And so if it's a negative f of x, then it's odd. If it's a positive f of x, it's even. If it's not our original function at all, or some weird mixture of positives and negatives, then it's neither, right? The other thing, this is a 5x to what power?
The first?
Yeah. And so 1 is a what sort of thing? 1's an odd number, right?
Oh, yeah.
And so if we're doing polynomials, there's a bit of a trick you can do with polynomials, and that's to look at the power in the polynomials. With that said, if I have like something like 2x minus 1, there's no x's on this 1. So if I wanted to think about a power to this thing, how could I put an x on here? I would have to make it x to the what power?
First, yeah.
This is a first power. This would have to be, there are none.
Hmm.
So what number can I put up here?
2.
Nah, what's x to the 0?
Sorry, could you repeat that?
What do I get if I do x to the 0?
Oh, 1, right?
Yeah, so there's no x's, right? This is sort of those things like those math hallucinations. You have to start seeing things that aren't there or whatever. But
Mhm.
x to the 0, right? If I have a constant, I can think about that as having no powers of x's on it. So if we look at this one and we look at the powers, and I know 62 wasn't one of the ones we did, but if this has an odd and an even power, if it's a mixture of powers, I'm going to do it without proving it real quick. But right away, I can kind of justify to myself that this one should probably come out as neither. If I look at something like, we didn't do 66, but can you guess what this one would be?
Neither.
It's a 6 and a 2.
Makes it. Oh, I can't see that small.
Okay. And 6 and 2 are both what?
Even.
Even. So this one should be even. We still do need to check it by throwing in the negative f of x, or the negative x into the f of x. But if you're looking at just polynomials, right? If you look at the powers in the polynomials, that should be able to help you, hopefully. And so we have nothing but odd powers. This thing is going to be odd, right? We said that this thing was odd. If it has odd and even powers, it's going to be neither. If it's got nothing but even powers on it, ooh, it should be an even symmetry. What happens when you have an even number of negatives? Like negative times a negative, it becomes what? Positive, right? So that's kind of what's happening in here. If we notice, clear it. So if we throw in a negative x and we do some work in the middle, but it ends up becoming minus the f of x, is that legible here in this gray? I feel like that's getting less legible. Maybe I do need to do a brighter color. So the test to do even or odd is to throw in the negative to the x. And if I end up getting a minus f of x, these are odd.
Depend of the power.
This is the way we check. The powers and things are a consequence of this definition.
Teacher, look at which number? 68. We have minus f of x equals to minus x power 5.
Mhm.
This one, it's not even. And it's not odd. We can say odd if it's because if the number is odd, but I think it's neither.
Okay.
Please.
So yeah, these are the definitions that you should use to check it. And like I was saying, if we look at polynomials, the degree on the polynomial, you can sort of check your own work without, you still want to do this, right? You still want to do the definition, but you can kind of check like mentally to make sure you're in the right direction and to make sure things are working out correctly. This one should be odd, and I'll check it in a second. This works for polynomials. If I give you something like, I don't know, cube root of x, right? That little trick isn't going to work. And I believe cube root of x is an odd function. It's got odd symmetry to it. So that little trick of looking at your powers on your exponents, it really only works if you're working with polynomials, right? When we get to like cube roots or, I don't know, absolute value of x, right? That had an even symmetry if we think about it. So this trick works, but it works kind of only with polynomials. And you should probably still be able to like do this definition and to check it from the definition. So to check it from the definition, like number what, 68?
Yes.
All right, so we want to check it from the definition number 68.
F of minus x
I'm going to
equals
share it on this one. This one's easier to write on. Stop sharing screen. Okay, do whiteboard. The graphs are hard to draw out. I didn't want to draw out every single graph. But if we do 68, f of x equals what? Minus x to the fifth.
minus,
If we throw in a negative to our x, how does that affect this thing? I still have the negative
yeah, it's
something
odd.
to the fifth, right?
It's odd.
And so what am I throwing in here? Sort of like this thing, right? That's the thing I'm changing. So now I want to throw a negative x into there. So what does that look like? Have a negative x to the fifth. So I want to evaluate just this thing right in here.
Okay.
So if I evaluate that, negative x, and I do it 5 times, overall, is that negative or positive?
It's a negative.
It's negative because I have 5 negatives.
Yeah.
Want to write them all out? Do be my guest, but I'm not going to write them all out. I have those 5 negatives. That counts for that thing, and I still have another.
Negative. It's going to be positive.
And so I end up with a positive x to the fifth. How does that relate to my original function? Is that the same as my original function?
No, it's the opposite.
It's the opposite of it. It's like I took this and threw another negative on there, right?
Right.
So since when I plug in this, I'm starting with this and I'm ending with this. This is the definition of odd functions. Yep. So if I throw in a negative to my x and I end up with the opposite, that is odd. If I end up with the same thing, it's even. So I don't think we've done an even yet. We do 61, 67, and 69 were the 3 we had. So I know I'm dancing around a little bit.
I think the even one teacher here is the 65.
Oh, okay. So let's look at.
65 is the even one. Yeah.
Well, let's look at 63.
Okay.
So if I do f of x, and this is equal to x squared minus 10.
Minus x squared. Yes, it's even.
If I do an f of a minus x, what does that give me?
Minus x squared.
I get a minus x, and I'm squaring it, and then I'm doing what?
Minus 10.
Subtracting 10. So basically everywhere where there's an x, I'm going to throw in a negative x into it. And so if I take a negative x and I square it, what am I going to end up getting?
Positive.
This is going to become positive because I have an even number of negatives.
Yeah.
And I still have that minus 10. So how does this relate to my original function? X squared minus 10. Is that the same as my original function, or is it the opposite?
It's the same. It's even.
Exactly the same. And so what happened is when I went and threw in a negative x, I ended up getting my same function. And so what does that tell me? This thing has to be
Even.
even. That's the definition of even right there. Now, can we use our little polynomial trick to maybe check and make sure this is all even? X squared is even, right? What about that minus 10? What power of x is on there?
1. No, he's yeah, he's 1.
No, there's no x's on there.
Ah, no x, sorry. Yeah.
So if there's no x's and I want to put 1, I can always put x to the
Just for
0.
x.
Yeah.
Mhm.
On your constants, you can always put 0 powers of things. It's not going to change it. X to the 0 is just a really stupid way to write the number 1, right? Okay. So this is what, 63?
Mhm.
61. Did we get 61 yet? Looks like f of x equals x plus 3.
I think it's neither. 61 is neither.
Okay, so if we throw in an f of a minus x,
Mhm. Minus
and
x
we know
plus-
what f of x looks like, maybe we also want to maybe picture in our head, what does the negative f of x look like? It looks like a negative of like this thing, right? Negative x minus 3. So I'm hoping like maybe in your head, you're also thinking about what the negative of this thing might look like. So if I do f of a minus x,
It's minus x plus 3.
it's minus x plus 3.
Yeah.
And is that my f of x? Is that my original function? Or is that
No.
negative f of x?
That's the opposite. So.
The opposite should be minus x minus 3. Is that the same as the opposite?
No.
No,
No, because it's got a plus right there. So these things,
I had it right. Neither.
it's neither.
Neither. Yes.
So these things you have to be really, really careful with those negative signs, in case you didn't realize that already, right? That's basically what we're doing. We're throwing in a negative and seeing what happens. Is the negative going to get like squared and like kind of simplify out? Be the same function to begin with? Then we have an even function. Or are we going to like do it a cube, right? Are we going to do a negative 3 times and then everything's going to get the sort of negative treatment? We're going to end up with the exact opposite of our original function. Okay, so that was what, 61? Did we do? We did 63 already, right?
Yes, we did.
And 67 would be the other one. So f of x is x to the third minus 2x. And so if we want to check it, the process is we want to throw a negative into our x. And so how does that change my formula? How many different things am I plugging it into?
Minus x cubed minus
Who's
2
next?
minus x.
Fernanda? Are you getting this? Where's she at?
Would this one be even since they're both like positive?
What would my function be if I plug in a negative? How many different spots am I plugging it into?
Does that turn negative now?
You're like cutting out a little bit there.
Would the x3 turn negative?
Oh, yeah, we have to plug in a negative x to this thing.
Mm-hmm.
And we also have to plug it in where?
Yeah, right behind the 2. Yeah.
Yeah, right there. So that has to become a negative x. That has to become a negative x. If I do minus x to the third, is that a positive or a negative x?
Wait, can you say that again?
So if I do a negative x to the third, I'm multiplying negative x times negative x times negative x. Overall, is that positive or negative?
Would it be positive?
So if you have 3 negatives, is that going to be negative or positive?
Negative.
It should be negative, yeah. So if you're doing negative of 3 times, it should be negative x to the third. And negative 2 times what? Negative x gives me what?
Positive 2x.
Positive 2x. Okay. Is that my original function? Is the first thing you should ask yourself.
No, because this one's negative.
No, these signs are different, right? So then if I factor out a negative 1, what happens? I should get what? X to the third minus 2x. And so what does that look like? I have a negative 1 is x to the third minus 2x, my original function.
Am I solving now for this?
So if we're looking at this, how does that relate to the original function?
Oh, they look the same.
Yeah, it's the same.
Mhm.
So if I can factor out a -1 from everything, what does that make this? Now we're looking here and here. What sort of symmetry is that?
Uh, since they're both like negative, wouldn't it be
Right.
uh
Ooh, running into the
maybe
edge of my
odd?
stream. So this was the sort of thing I had written earlier. So if we plug in something to an even, it should end up with the same as our original function. If we end up with the opposite as our original function, that is
An odd.
yeah, that's the odd definition. So if we throw in a negative, we end up with the same function, it's even. If we throw in a negative and we end up with the opposite, so I know I kind of did it here without talking about it, but factoring out a -1 is also another way you can see whether it's the opposite of the original function. If we can factor out a -1 from everything,
Yes.
that's just the -1 times the f of x, right? Or the minus f of x.
Yes.
So either you can try to maybe factor out a negative from everything. The other way you might be able to see it is if you just wanted to right off the bat sort of think about what your f of a minus x would be, or minus f of x. Right, would be what, minus 1 times x to the third minus 2x. You could do it that way as well. But somehow we're gonna have to recognize what a minus f of x is gonna look like, either by factoring out the negative or doing it beforehand and checking.
Okay.
Questions about this one? I feel like the even ones might be a little bit easier to check symbolically. The odd ones, we flip it and we flip it again. There's 2 flips. Too many flips, right? Okay. What was that 61, 63, 67, and the last one is 69. Is there a way, well, let's rewind just a second. X to the third minus 2x, and we said this thing was odd. Is there a way to check this with that little polynomial thing I was talking about? Were you expecting it to be odd before you even did it? Why or why
Yes.
not? Because we have a 3, and what else do we have?
Square.
No, that's x to the what power?
1.
It's 69, teacher?
Oh, I was going still 67, x to the third minus 2x.
Ah, sorry, because I'm
Yeah,
looking
yeah,
for
yeah.
69. Sorry.
Yeah, that's a square on 69. Yeah, no, 67 has a 3 and a 1, right? And these are both what?
It's odd.
Those are both odd numbers, right? And so anytime we have an odd number, if you throw a negative into an odd number, what happens to it? It's going to come out of that, right? And so that's basically like what's sort of happening. If everything is odd, we're going to get the negative to come out of everything. And if we get the negative to come out of everything, we're going to end up getting the opposite of our f of x. The negative factors out of everything. If it's even, and everything's even, right? Like, I don't know, x to the 4th and x squared.
Mhm.
And I could go throw a negative in there. What's going to happen to my negative?
Be positive.
Yeah, it just kind of disappears with those squares and those 4ths, right?
Yeah.
And so if it's kind of disappearing, I'm going to end up with the thing I started with. If you have an even number of negatives, it becomes a positive. If you have an odd number of negatives, you're going to be able to take a negative out of that thing. And the last one was what, 69? So I want you to think about maybe before we even do it, like what is it going to be?
Neither.
If we
No.
throw in what, f of a minus x, what's going to happen?
Square. It stays the same. It's opposite. No, it's odd. It's going to be odd because you have square, then the other is
We have square and we have a cube. So what do we know about
cube.
those things? We have a 2 and a 3. So a 2 is even, a 3 is
Odd.
odd. So is this even or odd?
It's odd. Why? Because teacher, look, minus x squared, it's going to be x squared. And minus 3 minus x cube, it's stay minus x. Yeah, it's even.
So if we
It's
throw in a
even.
negative to each of these,
It's even.
the first one's going to be what? X squared is going to become positive x squared, right?
Mhm.
This is going to be minus, and I want to fix this thing up. But if I do this 3 times, this thing is also
Minus.
going to have a negative there, right?
Yeah.
And this is going to be what? X cubed.
Yeah, plus x cube.
So this is going to end up becoming x squared. We have 2 negatives here now.
It's plus.
X squared plus x cubed. So we know, is that the same thing as my function?
No, no, no.
No, so we definitely know it's not even. The other thing we want to check, is that thing odd?
No, it's
So what would minus f of x look like? That would look like if we took everything and negated everything, that would have a negative x squared and a positive x cubed. Is that what we have here?
No.
No. So this is off by a negative sign either way we look at it. So this one is
neither.
neither. And before we even started, I see a 2 and a 3. One of them's even and one of them's odd. And then you ask yourself, is this even or odd? It's a mix of the two, right? So it's got to be neither. So it's even only if everything is even, right? And it's odd only if every power is odd. If you get mixtures of powers, then it's going to be neither. I hope these like 3 concepts kind of match up to you. Because if I come out here, I don't know, here's my graph here. If I want even symmetry, right? If I come out here and I want to negate it over here, this thing should look the same way, right? And then the other way is what? Odd. If I have a function and it looks odd over here, if I want it over here and I pick an even quantity, I want the negative quantity to look the opposite of it. So if this is up, I want this thing to be down, right? And vice versa. Okay. I think we're getting there. Are there questions over these symbolic ones? Any ones you want me to go over? If you want me to go over another one, we can go over another one. If not, I want to get to those tables. So 79, let's do 79, 80, and 81. I know 80 is not a sign there, but I think it'll do some good to get like with one flavor of each, basically. So I think I'm going to give y'all like 5 minutes or so. I think I'm going to open up the rooms for 5 minutes and then we'll come back and finish this up. I know it says 9 minutes. I'll bring them back early. The even and odd functions is with tables. I will say this. I feel like the graphing is probably the easiest. I feel like the symbolic checking is probably the hardest on this. And I feel like this one's probably right in the middle. So if you think about these would be like my x's over here. And this would be like, what if I plugged in a negative x? So relating this back to maybe the symbolic sort of thing we were doing. If I have a positive x, how does it relate to the negative x if I plug it into the function? Next, Jerry, are you getting this?
Yeah, sorry. I was doing the other ones. We're on 79, right?
Yeah, 79. So I get what? -5 if I plug in 1. I get a +5 if I plug in a -1. So
For that one, I put odd.
So this symmetry is odd, right? Because if I flip the x, the y also gets flipped. So when we're doing things symbolically, basically what we're doing is we're flipping the x and seeing what happened. Here I noticed what 5 and a -5, those are opposites. 23 and -23 are opposites. So this looks like odd. There's one other thing I should really check besides those numbers.
The origin or the
The origin right in the middle. It also has to go through the origin. So this is odd symmetry and what it looks like in a table. If I flip the x's, the y's also get flipped. So there should be some sort of origin on each side of the origin. We get a positive and negative x. And the y's are opposite. All right, so that is an odd symmetry. What if I do 10 in here instead? What would you say then? It doesn't go through the origin, but all these other ones look like they're odd. If it doesn't go through the origin, right? And it's gonna be
neither.
Yeah.
It's negative.
Yeah. So if they give you anything that's not the origin, right? You can right away tell me it's not odd. And if it's opposite and it looks like it should have been odd, then it's neither, right? Okay. So what about this one? If we look along here, how do these match up? If I do the x versus the negative of the x, how are those things matching up?
They're the same.
They're the same. So what does that make this?
Even.
That's even. So if you're looking at it and you're negating the x and they get the same thing, whether the x is negative or positive, it's an even function. And then the final one, they want this to be even. So I'm going to ask you, I guess, what should I put over here then? What goes in that
Negative.
positive one if it's even?
Negative 25.
Yeah. So I hope you're telling me 25. And is it negative or positive? It's got to be the same sign. And what about this? What would I put at -2?
Negative 12.
Negative 12, the same thing that's in +2. And then what's in what? 3 should be 21, same thing that's in the -3. The only other thing is what? 0. I think you can literally put any number there if it's even, right? 100, if you want to be really crazy, make people draw it. I don't know. You can literally put any number there if it's even, because it doesn't really matter where it goes through the axis. What matters is like these things are even on each side, right? So that when we draw it, we're getting an even thing. If I want to do it way up here, I could do it right up there, right? I could do it way down here. It's still going to be even, no matter where it goes to the y-axis. So when we're doing even, it doesn't matter about the origin. We don't care. We don't care where it goes through here. You can literally put any number there. Everything else, you should put the right numbers, right? That's -25. This is what, 21. And this is what, -12.
Yeah.
These two things should be syncing up for even.
Maybe in 0 we can put 5.
All right. One thing I want to talk about right before we're almost there. We're at the end of class. But one thing I want to talk about right quick is the number of solutions from the previous chapter. So if we have something like, let me do a whiteboard right quick. If we have something like, yeah, a graph like this versus a graph like this versus a graph like that.
Well, they're going to be doing their homework corrections tonight, so they'll know what we're talking about. It's 9.3.
Okay, so a lot of people told me like what, 2 imaginaries, is that what they're saying?
Yeah, they kept saying 2 imaginary or 2 complex, but they weren't answering how many real ones there were.
1 real and 2 real. How many reals are in this if I have 2 imaginaries? How many real solutions would be in this one?
0.
Yeah, so there are 0 real. So knowing and answering what they're asking might be kind of key here. I know you might know it, but we also don't know what you know. So
I wasn't sure about that, so I put 0 real and 2 complex on that one.
oh, if you told me
Yeah.
0 real, then you told me how many real are there.
You
that
were
was
the only one who did that, though. Everyone else just wrote 2 imaginary or 2 complex.
Right.
You're the only one, Michael, who wrote both.
yeah. If you're telling me 0 real, that's what they were asking. Like, how many real solutions are there? If you tell me 2 imaginary, I don't know whether you know there are 0 real solutions. You know, specifying there's 0 real was kind of the issue there. If there's 1 real, it's repeated, right? So also knowing that there's 0 imaginary and it's 1 real, and it's 1 real because it's repeated, right? That's also something you should kind of know. And if it's 2 real, then there's 0 imaginary, right? Here as well. So knowing these solution patterns, I know that we just threw them at you, but they're gonna pop up and pop up again. So I want to talk about them right quick.
Another thing to mention on that homework was the directions say calculate the discriminant. You need to show us that calculation. You can't just say